Welcome to the session. Greeting of the day. In the previous classes, we are discussions about sensors and transducers, and after that we are seeing about this signal conditioning process. Even though the measured quantities will be in a regular format, but the amplitude of those things will be vary. So sensors sense physical phenomena such as the rise in temperatures, and convert the measures value into the electrical signals. So like voltage or current, this we know. So however, the signals may not be in the appropriate form. What is this appropriate form? So employing them into the controlling the mechatronics system. So from the non-linearity to the linearity we should change. The signals that we are obtaining will be in the non-linear format, or the signals which we are obtaining will be in the low amplitude format. So such cases we should increase wherever it is required, or we should decrease wherever we need. This process is done by the signal conditioning devices. The signals given by the transducers may be a non-linear, in nature of may contain the noise. So therefore, thus before sending the signal to the mechatronics control system, we should reduce this noise, which is to be done by this noise or non-linearity will be vary. So it is needed to modify this amplitude from the low or from the high and from analog to digital formats, from analog to digital or digital to analog, to be done for the suitable mechatronics control system. So these activities are carried out by using, that is what I told you in the previously, the signal conditioning devices. What it does, we can see from the non-linearity, it is changing to the linearization forms. The way irregular phase can be normalized to the required waveform. Okay? This is how. Low amplitude to the high amplitudes, from the noise level to the noise free levels. These things we have seen in the radios. Everything, the noise is high, we will tell generally these words. That's nothing but a frequency which is very nearer. The words coming very nearer. This is to be converted into the normal formats. Okay, and from the analog to the digital concerns, from mechanical to the electrical concerns that we are doing. So these causes are done by this signal conditioning devices. So I am dividing this signal conditioning into two sectors of number one of amplifier, which is less to be amplified. Second one, which is noise, is very amplified, it is very noise, to be noise free, to be reduced. There I am using the noise reduction, and there I am using the word filters. Some filters we will see, where the band gaps, the band which is to be skipped out, the band which is to be kept. So this amplifiers and noise reduction filters comes under signal conditioning part. First one, why we should do this signal conditioning process? For number one, the protection, to protect the damages to the next element. So in case if you are supplying, let us take the laptop charger, if you are supplying more watts, we are telling 65 watts, 95 watts charger, if you are supplying more watts, what happens? If irregularity of charges comes inside, the charger protect the laptop from the damage. So similarly, this all comes under noise reduction, signal reduction processes. So likewise, to protect the damage for the next element, this is maybe the laptop, okay, of mechatronics system, like microprocessors, from the high current voltage signal. That is what I told you, 65 watt or 90 watt. Right? So such examples we have taken. So right type of signal. So second one I am talking about the right type of signal. Which signal we need to convert the output signal from the sensors into the desired from voltage or current sectors. The temperature converted into voltage, strain measurement, displacement converted into the electrical format. Okay, light sources are converted into the sounds. So such cases we are doing. So which format we need there? Signal conditioning manipulations is needed there. Maybe damage, a right format, a right level of signal. It is voltage, it is current, but what happens? It is very high. Not possible to hear. The frequency is very large. Not possible to see, or color changes may happen. So those things, the right level, how much it is, what hertz they will tell, 50 hertz to 60 hertz, 70 hertz to 100 hertz. Those level we should maintain here. Okay. So to amplify or detonate the signals to a right acceptable level for the next element. So next element should not be damaged. Next element should be accurate to convert the right signals. So these things noisy. To eliminate the noise from the, see, this is general, this is what totally we are seeing. Manipulation, to manipulate the signal from its non-linear form to the linear form, the non-linear form to the linear regular format, the uniform format. What is uniform here? This is both are uniform format. Those things we have to do. The various applications of Mechatronics systems such as CNC machines, to our relative CNC machines, machine tool control unit accepts voltage amplitudes in the range of 0 to 10 volts only. But you see, however, many sensors produce signal from the millivolts. Here it is volt. Here it is in the 10 volts. This is to be converted into millivolt for this sensors, signal conditioning units, microprocessors. But CNC machine work at this gives the output at a 10 volt, but this microprocessor receives at a millivolt. So this low level input signals from the sensors must be amplified to the use of further control action. So we are doing, whether it's a reduction or whether it is an amplification process, we should do through the signal conditioning systems. Operational amplifiers, op-amps, are widely used for amplification process. For amplification, we are using the setup named as amplification, operational amplifiers that we see. Right, number one I have taken here about the operational amplifiers. This is one amplification module. So it is often abbreviated as operational amplifier. Okay, now we came to know. Operational amplifier is a high gain voltage amplifier with the difference input. We are giving amplification process. How it does it? This amplification process works like a mathematical calculation. It means two inputs it need. It compares the both and gives the difference between it, and it amplifies whether it should be high, whether it should be high, whether it should be low. Those things are differential input. They are comparing 1 minus 2. Likewise, it does not mean it is negative. It compares the differences, how much it is. The differential input is a method of transforming information with two different electronic signals. We are taking two signals here. Whether temperature to be maintained, what is the temperature there, what is the temperature here. So they compare the average, and then it is to be amplified high or low. That operation amplifier works on it. It has 5 terminals that we see. How the setup looks like. So it has 5 setups. 2 input voltage are applied to the 2 input terminals. I have the number 1 and number 2. 2 inputs I am giving. Here I have given as non-inverting input V plus, non-inverting input V minus. It does not mean it is positive. It does not mean it is negative. It is a representation that 2 values, one we taken as, just for symbolic I have taken as plus, just for symbolic I have taken as minus. Second, 2 external power supply for the working of operation amplifier applied as Vs plus, Vs minus, voltage supply plus, voltage supply minus. So I have supplying 2 sides. Power supply I have given for these cases. This is related to non-inverting input. This is related to inverting input of power supply. We should, for the operational of this module I am giving. So I am given as here as V S plus 1, okay, and 2 here, sorry, V S minus. Supply, I give 2 direction. This is I am considering as a second one. So 2 inputs, 2 power supply I have given. This is to be compared. It is not a positive, it is not a negative. I am just comparing the difference between it and whether it is to be amplified or it is to be reduced. Those things will be done by this amplification process. So one output, finally we have the one output terminal provides the amplified value of a difference between these 2 input voltages. The difference only it is providing. It will not provide minus values. Okay, something you should understand here. In general, operational amplifier amplifies the difference between the input of V plus and V minus. What I told you here, that is one. It compares. The output of an operational amplifier can be written as voltage output V out. This is V out. V out. Of an amplifier is written as V out equal to operational gain. It is a constant we are adding, and V plus minus V minus. Minus is the factor where the difference is to be found. V plus is a symbolic word of input 1. Symbolic word of input 1, and this is a symbolic word of input 2. It compares between these two and it will be amplified. So a simple diagram we should understand and we can write. So it is used as a mathematical operation. I told you now only. It is used as a mathematical operation like additions, subtractions, multiplications. Okay, these things it does. We need 2 inputs to perform mathematical operations. Yes, we need 2 mathematical operations. 1 to 1 we should compare, means only one numeric value. If you are keeping 2, it cannot be. 2 minus 4 it can do. Okay, likewise. We are just representing the input 1 as positive. What I told you earlier is the same. Input 1 is positive, input 2 is negative. It is symbolic. Input 1, non-inverting input. If the input is positive, output also positive. Given input, output polarity will be the same. No phase change occurs here. Whatever it comes, it gives as it is. If the input 1 is activated, right? Second, this non-inverting is represented as a positive symbol. Only symbol this represented as a positive symbol. Inverting input, if the input positive is equal to output will be negative. Gives input and output polarity will be inverted. So here the polarity we are changing. We are naming this as a 180 degree phase shift. So it changes. That we are symboling as a negative value. This inverting is represented as a negative symbol. So the input can be in the positive V plus it may, and V minus it may. Whichever input it comes, whether it comes in the positive, it will be amplified in the positive value. Whether it comes in the negative, it will be amplified in the negative. 180 changes occurs. Right. So the applications where we are using non-inverting amplifiers, we know this. Inverting amplifiers, so whether it may be a inverted type, whether it's to be reduced or it's to be gained upward. Inverting, non-inverting. Okay. So the oscillating waveforms. So this waveforms to be large waveforms or to be small waveforms. Okay. So comparator, as a comparator mathematical comparators we can do here. So such cases are possible. So now we have done about the amplifiers part. Next we have to do about this noise reduction. We have compared two. One is amplifier and one is noise reduction and filtering process. So that noise reduction I am coming. Okay. So the output signals from the sensors contain noise due to various external factors. What are they? Maybe improper hardware connections. This we have seen this noise in the TV channels. The cable connection is not plugged in properly. Some frequency will change lightly. Some shaking will happen in the TVs. Or noises will come in the radio also will come in the phone also will come. So these noises are due to hardware non-proper circuitry connections. So that we have changed improper hardware connections and environmental factors also. The tower, the receiving signals from the tower to the phone, the noise changes due to this environmental efforts, temperature changes, or else the airs, so whatever it is, okay. So the noise gives an error in the final output system, therefore it must be removed. How we are removing? In practice, the change in the desired frequency level of output signal is commonly noted as noise. In practice, change in the desired frequency. Here we are using the frequency word. We should know what is frequency. We'll see now. A small image I have, I will show you. A change in desired frequency level of output signal is commonly noted as noise. This can be rectified by using the filters. So we have a noise signal. It may be like this, okay, or it may be like this, or it may be goes slowly. The reduction of noise may take place. Any graph will come. Those graph where we need. So I am considering this first part as noise, and here I am talking. The amplitude of talking increases here. So likewise, we should consider. I am taking this following types of filter are used in practice. What are they? The low pass filter, the high pass, band reject filters. This pass means we should pass. We are allowing. The low allowing. It means here in the graph up to this level of condition I am allowing. The noise level, the recording we are talking, it is recorded as a voice. So recording frequency I am telling this as how much it is. Okay, slowly I am starting to talk here. So but when I am not talking, the frequency is not there. When I am talking, the frequency immediately increases. Okay, the non-talking zone will be the noise. Like the AC sounds will be there. Slightly when we are talking background, the noise signals are there. So where it will be, the noise signals are here. And when we are talking, the frequency are increased and it is here. Okay, so this is noise. It is to be rejected. So the low pass I am maybe rejecting or accepting. So a small graph you will see there. So likewise, the low pass we are accepting, high pass we are accepting. So here I am rejecting, and high pass this way I am accepting. This I am accepting, or otherwise this I am accepting. Such conditions. So here I would like to play a small video clip of running of the ambulance here and there. When it goes front, we receive more noise. When we receive more noise there, but when it goes backside to us, we won't receive noise. This is all based upon this waveform and the frequency. So let us consider, I am throwing a stone in the water. We could have seen the waves on the water when you are looking from the top view. It creates like a waves here. So this is at the center. This is one wave. This is second wave. This is third wave. It means the flow. The waves are created. So when this is the gap is equally distributed now. This is called as a wavelength. This is called as a wavelength. See, likewise it distributes. So this we call it as a wavelength. How fast this waves are crossing one point. I have one point here, and waves are moving, and the waves when it is moved, how fast it is crossing. In case the ambulance is here, and the sound waves are created, and the air molecules are shuffled, and it creates a wave. And when the ambulance is moving in this direction, the waves are very nearer. It is pressing by the action. Therefore, so it happens like this. See how far the wave, so in case the waves are more, frequency are large. In case if waves are less, frequency will be. So now a small example we will go ahead. On the ambulance, when the uniform wavelength or frequency is generated, I am standing here. I am receiving a noise in a silent way. When this ambulance is moving forward, what happens? These waves are compressed. Therefore, more waves are there, more frequency are there. It means more frequency, per second it will cross 10 frequency per second, 5 frequency, 12 frequency per second. In the same way, when at the back side, we are moving at that side, we are not giving the pressure back side. So wavelength is length is large. One wavelength to another wavelength is very large and it crosses slowly. There is no pressure. So see, a small, that we understand now. So see, when I am crossing, this is the equal in length everywhere, this is equal in length everywhere, but when it is activated to move in front, it is pressed everywhere. Then what happens? It presses and it creates the wavelength, less wavelength is generated, and therefore the frequency is large. But in this direction wavelength is large, this wavelength is large, and frequency also very less because it crosses very slowly. So this I am naming this as a frequency and wavelength. Now we come back to the low pass filter. The low pass filter is used to allow low frequency of content and to reject the high frequency content of an input signal. So here the frequency is there. In the x-axis I have frequency, in the y-axis I have signal transmitted. How? Now the signal transmitted in this direction it is available. I am talking here, I am not talking, I am talking here. This I have started to talk. In case this talking is not required, I need only this AC running sound. Okay, what I am doing, what I can do, I can able to pass this band only. So from here to here, this frequency to this frequency I am cutting. Okay, that I am not permitting. So this setup only I am permitting. So what happens? Low pass filter used to allow the low frequency content. The frequency which is first initially started. Other frequency, these are all high here. I am not permitting. First frequency I am permitting and reject the high frequencies. This is mentioned as a low frequency content. Next one, the high pass filter. So what happens? The name itself says it is high. The name itself says it is high. What happens? High pass filters are used to allow the high frequency to pass. Okay, we are passing now. So through it and to reject the low frequency content. Okay, here I have AC noises, and after that I am telling welcome to the session. Okay, so what happens here? The noise increases. It means the voice level frequency increasing. So that from there I need the voice, from there the need. So what I am doing, this region I no need. Okay, so there the passing band is this is pass, this is pass, this I need. So what it is, high pass filter, this is we are naming as a high pass. So whether it is required to talking more signal transmitted is high, then it is high pass filter. If the signal transmitted is low, then it is a low pass filter. Whatever we are doing, that it takes accordingly. So high pass filter is used to allow high frequency to pass through it and reject the low frequency content of an input signal. Okay, so this is it. And then another two are there. Band pass filter. So earlier we have seen low pass and high pass. The band is in the middle is something I need. In the middle is something I need. So this is in the middle is something I need. What I am doing here now, in some applications we need the filter in a particular band of frequency from a wide range of mixed signals. Okay, so what I am telling, let us consider the fan is running. Okay, and then the AC is running. Okay, and myself also talking. Okay, so these things all happens. Now what I need only my talkings, and also in this high pitch band. So I have started here and I am going well here and I am coming here and taking. So this I need. Which one I need now? Which? The high pass is there I need. So I need from here to here. I need from here to here only. This band I need. The before I know it, the later I know it. I need at the center high signal band. That is what this image represents. So here it is started, but I don't need this. Here I am ending the voice, the talking stopping, that I don't need. Where I am continuously talking, this region belongs to this signal transmitted, this zone I need. So I can able to cut the specific band that we call it as a frequency band that I need. For this purpose, the properties of low pass and high pass filter circuits can be combined to design the band pass filter. So I have taken the low pass, I have taken the high pass, I have combined and I am utilizing as a band pass filter. So center band I need. Beforely, first one we used, second this side we used. Now the center I am using. Okay. This filter pass the frequency which is between certain band. This filter pass the frequency which is between certain band and rejects all the frequencies which is outside this band. So I am fixing this band signals. Outside the signals, this everything will be in reject mode. So these things. So see a small the same example I also some attached here. So the frequency in this x axis and the gain in the y axis. I want to pass the pass band here I have taken. So the pass band here I have taken up to this signal. This is pass band. Okay. Here it is a stop band. Here it is stop band. See, it is stop band. We are not considering. And similarly, this is also the stop band. Here also we are not considering. I need this band pass filter at the center band only. So this is the transition bands. So from here it is transition. The name, just name identifying transition. Again from high to low it is transferred. This we are not pausing. We no need according to these cases. So likewise we can able to do. Right, the band reject filter. What we have done here, this filter passes all frequencies above and below particulars. This passes all frequencies above and below particulars. So that the center part I am rejecting here. See, and the center part I am rejecting. This side I need. This side I need. This side I need. So what happens? I no need this zone. So earlierly at center part we accepted. At here the right and left away parts which we have rejected earlier, that we are rejecting here. So these are the causes of making the band pass filters. The summary of the session. In these units, we have seen about how many minutes are there? Okay, see the summary. We have in this subject we have seen about this semiconductor material. There we have seen about the N type, the P type, and we have combined this to form PN junction, and from the PN junction we call it as a diode, right? And then from the PN junction we formed PNP. This we call it as a transistor. From the transistor again we have derived the diode, right? Here we have added a small subtract and the track, diode and track we have added. So afterwards again we have seen this amplifiers, noise reduction, signal conditioning units. So this is how we completed this topic of subjects. The remaining part of the subject we will see you in the next session. Thank you.